Okay, another example of a polar graph. Let's do this one by hand. So we're inputting a 0 for theta. So sine theta is sine of 0 is 0, plus 1. When theta is 0, radius is 1. Pi over 6, sine of pi over 6 is 1/2. Doubled is 1, plus 1 is 2. So if we go out here on the graph about pi over 6, our radius is going to be 2. At pi over 4, sine of pi over 4 is approximately 0.7. So 0.7 doubled is 1.4 plus 1. So this is approximately 2.4. So I'm going to go in the direction of pi over 4, about 2.4 units. Next, sine of pi over 3 is root 3 over 2, which is approximately 0.9. Double it. That would give us 1.8. Plus 1 would give us 2.8. So going in the direction of pi over 3, about 2.8 units. Maybe it's got to be a little bit closer to 3. Let me move that point out. Okay, at pi over 2, sine of pi over 2 is 1. Double it and add 1, we get 3. 2 pi over 3, well, since sine is the same in the first and second quadrants, these are just going to be mirror images of these values. So this graph is going to be symmetric over the y-axis. So this is 2.4. Okay, so if we follow the polar curve around, we're going to get a shape like this so far. Okay, keep going. So sine of 7 pi over 6. So that's going to be negative 1/2. So negative 0.5, double it. We're going to add, and then add 1. That's going to come out to be 0. So what actually happens here is this guy's going to actually dip a little bit below the axis between pi and 7 pi over 6. Okay, 5 pi over 4. Sine of 5 pi over 4 is now approximately negative 0.7. Double it. That gives you negative 1.4. Plus 1 is negative 0.4. So we're going to go in the direction of 5 pi over 4, which would be in this direction. But then I'm going to go a distance of 0.4, but then reflect it 180 degrees. So that puts us over here. Uh, 4 pi over 3, sine of 4 pi over 3. Let's think about this. That's going to be negative root 3 over 2, so that's approximately negative 0.9. Double it is negative 1.8, plus 1 is negative 0.8. So going in the direction of 4 pi over 3, which is down here, a distance of negative 0.8 would put us down here, and then I'm going to reflect that over the 180 degrees, or kind of rotate it 180 degrees around the origin. Okay, sine of 3 pi over 2 is negative 1. Double it and add 1, so we're going to get negative 1. So I'm going down here, but then I'm going to rotate it 180 degrees and go the opposite direction. So we're getting this little inner loop. 5 pi over 3. Sine of 5 pi over 3 is going to be the same as the sine of 4 pi over 3. So again, we're going to continue with these same values that we had in the third quadrant. So in the direction of 5 pi over 3, a distance of 0.8, that would take us down around here. Let's reflect that over, and we end up here. 7 pi over 4, that's going to give us negative 0.4. That brings us right there. And 11 pi over 6, that's going to take us back to 0. And then when we go all the way back to 2 pi in the graph, we're going to end up where we started. So when you're drawing this graph, you have to go from 0 to 2 pi to get the entire graph. And to get the little inner loop, that little inner loop was from 7 pi over 6 to 11 pi over 6.